Asteroids are no longer just small, rocky worlds floating in space. They have become new economic opportunities and places strategic to space exploration.
There's almost unlimited resources on the asteroids. There are many different types, and they each contain different resources that we could use.
Most of them are made of metals like iron, nickel, or precious metals like gold or platinum that are very valuable. However, the most valuable material on asteroids is the simplest element: water. In the near future, we could use asteroids as pit stops to refuel spacecrafts en route to deep space with propellant made out of water.
That is where the value of asteroids really lie, as they become gas stations or pit stops or stepping stones in our process to explore further and further into the solar system.
In the last few years, space has become of interest not just to the public sector, led by national space agencies, but also to the private sector, resulting in an unprecedented industrial revolution. Several companies have plans to explore and use resources from asteroids. Most of these companies are based in the USA. However, there is a small country in the center of Europe that is playing a key role in this emerging sector: Luxembourg.
Luxembourg have become very interested in asteroid mining. They're bigger in space than they are on the ground.
But to make asteroid mining economically feasible, we need to solve some technical challenges.
The cost of sending a spacecraft to the asteroid belt used to be about the same as if the spacecraft were made of pure platinum.
Once those challenges have been overcome, we might start to dream of asteroids as our new targets, small, isolated worlds that could play a key role in future space economy.
I think there's a great analogy to the 1800s gold rush in the western United States for the economy of the future for the late 21st century out there in space.
You're looking for stuff that you want, and specifically, if you're going to turn an asteroid into a place for people to live.
We are about to be witness to a whole space industrial revolution that will see asteroids become our next frontier. In the last few years, several missions to asteroids have shown us that they have many resources that could be useful to us.
The advantages of asteroids are that they have a lot more favorable chemistry. The components that the asteroids are made of are a lot more of the things that we find valuable.
There is one type of asteroid, the C-type, also known as the carbonaceous or chondrite asteroids, that are the most abundant and have not just hydrocarbons, but also a key element for the future space industry: water. Water is an extremely valuable resource for several reasons. It will be necessary for resupplying. Astronauts could use asteroids as stops to refill the water tanks of spacecrafts in long, deep space journeys to destinations like Mars.
By having water on practically everywhere around the solar system, because there's millions of these asteroids floating around, you have the possibility to use water not just for humans. It's good for drinking. Water can be used to obtain oxygen. You can use them to shield you from radiation, to grow plants, whatever you need. But the real importance of water on asteroids is because you can use them as a means of energy, as a propellant.
You can just heat the water to steam and then use that as a rocket, a steam rocket. And that's a way to get around space. But another way is to take the water and split it by electrolysis into hydrogen and oxygen, and then then use that in a liquid hydrogen, liquid oxygen rocket, and that's the most powerful chemical rocket we have today.
So in a way, water becomes, as we say, the oil of space. Because once you have that propellant, that will help you to move around the solar system, get you to much further destinations. You will be able to now refuel, so that you don't have to bring that fuel from Earth. And so that allows you to have larger rockets, larger payloads, and truly they become stepping stones, or sometimes they call it pit stops along the way.
Several missions have recently explored or are exploring several C-type asteroids, as the Hayabusa 1 mission from JAXA, the Japanese Aerospace Exploration Agency, or 2 ongoing missions, NASA's OSIRIS-REx mission and JAXA's Hayabusa 2. All of these missions have the peculiarity of being sample return missions, which means that probes will grab some asteroidal material and will return it to the Earth for its later analysis. These samples will be extremely useful to know much more about the real composition of asteroids and will allow us to study their real potential as resources. There's another type of asteroid, the M-types, or metallic, which are made of nickel, iron, iridium, platinum, gold, or other precious metals, either pure or mixed in different proportions with stone. Those asteroids might be used as an endless resource of materials and minerals.
They also are important because some of those asteroids, the metallic types, hold important metals that are used for a variety of things, for construction, like iron and nickel, and also the valuable platinum group metals. So once you have those metals, now you have the material that you need to develop manufacturing things like, for example, tools or spare parts, or even large construction material for satellites.
There are even some asteroids like Psyche, which are made almost entirely of metal that could eventually become very interesting targets for the future asteroid mining industry, as the metals are on the surface and there's no need to dig deep to extract them, as happens here on Earth, greatly simplifying the mining process. The NASA mission to Psyche, planned for 2022, will allow us to know more about this unique metallic world. All the resources we can extract from asteroids might be really useful for industrial purposes in the near future once the space industry revolution has finally kicked off. Things have been changing very fast in the space industry in the last few years, thanks to the rapid growth of private space companies, the real game changers in the space industrial revolution.
I think we are entering a new era when private entities are taking a bigger role in space than they did before. They're creating a kind of more commercial market for new people to work and live in space that we didn't have before. And that's driving what I think is going to be a new era in space exploration that is less directly tied to government programs, but more commercial activity in space.
This new space industry has several main drivers. On the one hand, improvements in launch systems, sensors, and other input and innovations, such as the small-sat architecture, are driving down costs.
The new space concepts, this idea that there's this environment out there, a potential environment for economic investment and economic return that is effectively boundless. We live on a planet with limited resources. Space around us, the solar system around us, represents economic resources, mining, mineral resources that are effectively boundless.
The combination of decreased costs and increased capabilities of smallsats opens up new use cases, industries, and applications for businesses. All of these have led to the democratization of space, as it will be no longer just territory exclusive to huge national public space agencies, but also for any big or small private companies eager to invest in space.
That is what is pushing not just the governments, but the private industry and the rest of the world, not just the space-faring nations, but the rest of the world, as you're seeing now, is interested in entering this new phase of space. It will be not just for exploration, not just for gathering scientific knowledge, but to truly start using space to help us in commercial activities and economic ventures.
The key driver has undoubtedly been the increasing development of fully reusable rockets that will dramatically reduce the costs of launching. The main reason that space has been, up until now, an industry only affordable to huge space national public institutions such as NASA, ESA, Roscosmos, Russia, or JAXA, Japan. Private companies like SpaceX or Blue Origin, led by multi-billionaire entrepreneurs like Elon Musk or Jeff Bezos, are the ones that are investing most heavily in developing techniques to reduce launching costs. The development of more capable and increasingly smaller satellites is another of the drivers of this coming industrial revolution. Private companies like Planet or OneWeb are leading the production, launch, and control of these nanosats, which will radically improve our network communications, broadcasting systems, geolocation systems, or Earth observation. In addition to the aerospace industry, this space industrial revolution will also transform communications, the internet, tourism, the energy industry, manufacturing, and mining.
There's other opportunities in space entertainment and on-orbit manufacturing, things that will also create revenues and activity and create a demand for an on-orbit facility. I expect all of this to happen in the next 5 to 10 years.
The mining industry will focus especially on the moon and on asteroids as the easiest targets for obtaining resources such as minerals, metals, or water. Asteroid mining, which has belonged to the realm of science fiction until now, could become a reality in the near future. We may be witness to a 21st century gold rush.
The real estate plays when we start launching lots of people to space. It's going to be the manufacturing that we can get going on orbit. It's going to be all of the things that we can do, and you're going to need everything you can possibly imagine on Earth. We're going to need that in space. That's going to create an incredible amount of value. That's going to engage a lot of people.
There are 2 places in the world that concentrate most of the companies responsible for this revolution: California in the United States and Luxembourg, a very small country in the heart of Europe. Luxembourg is a very particular case. It could become the Silicon Valley of asteroid mining. This tiny state took a gamble on the space industry and nowadays hosts the SES, Société Européenne des Satellites, the world's leading satellite operator, with a fleet of about 50 satellites. This country is one of the main accelerators of this emerging space industry revolution.
Luxembourg have become very interested in asteroid mining. They're a fascinating little country, and they're a very little country. But in the 1980s, they helped to set up some of the first commercial telecommunication satellites. And now the largest telecommunication satellites in the world are from Luxembourg. So they're bigger in space than they are on the ground.
The goal of the Luxembourg government is to put into place an overall framework for the exploration and commercial use of resources from celestial bodies such as asteroids. An adventurous and unproven enterprise like space mining requires financial backing, legal frameworks, and favorable regulatory structures to allow the work to even take place. Luxembourg has expertise in this area, given its experience in the mid-1980s with the commercial satellite industry.
They're smart enough to know the financial industry, and they have a fairly concentrated economy in a couple of sectors. So they're now aggressively looking for other wins they can make. How can they get ahead of the game? And so they've realized asteroid mining, it's not just about the regulatory environment. I mean, it's easy enough for them to write favorable regulations so that it makes sense. But they also want to invest to move that forward and really cement their position in the asteroid mining industry.
Asteroid mining could become a big industry within the next decade, depending on how we solve the many technical difficulties involved. The first difficulty is to know which asteroids are the most interesting for mining purposes, as there are asteroids spread all over the solar system.
To know which asteroids to go to, we work with collaborators who have been studying meteorites and remote observation of asteroids. And from our observations, we can determine which type of asteroid it is. And the meteorites tell us kind of the range of possibilities of the mineralogy of those asteroids.
The data gathered by NASA, ESA, the European Space Agency, JAXA, the Japanese Aerospace Exploration Agency, and other space agencies in the last few years on near-Earth asteroids, the most easy accessible, will facilitate the selection of the best targets for asteroid mining companies. Another difficulty would be to decide the best way to mine, whether to bring raw asteroidal material to Earth for use or to process it on-site to bring back only processed materials and perhaps produce propellant for the return trip. Or even to transport the asteroid to a safe orbit around the Moon, Earth, or to the International Space Station. This could hypothetically allow for most materials to be used and not wasted.
What makes asteroids unique and different from other bodies like moons or planets is that they are so small that their gravity is practically zero. That low gravity is good for a couple of things. That makes it easier to get to them. The energy that you need to get to them is lower than even to get to the Moon or Mars. So they are easily accessible energetically, not necessarily on time. They may be far away, but it's easy to get to them in energy. But one thing about the very low gravity of them is that all the techniques that we have learned on how to mine or extract materials here on Earth are quite different when you get to an asteroid. You no longer have that gravity that can keep an excavator on the ground and the traction that you need to move around. These things will tend to float. So you have to design different techniques how to extract this material.
At the Center for Space Resources of the Colorado School of Mines, one of the most renowned space research centers in the world, different experiments have been developed to test the specific techniques intended for asteroid mining. The scientific team uses a sophisticated vacuum chamber to recreate the extreme conditions in space more accurately.
Here at the Colorado School of Mines, we focus on creating environments in which we can test mining equipment in space, or potential mining equipment in space. We have a large vacuum chamber in which we can create a low pressure environment that's similar to what we have in space. We can place simulants of asteroid surfaces that are dusty and will create a dust cloud as we work with them. We can pull a vacuum on it to bring the pressure down to a low enough that it's simulating space. And we can do other things like chill it to very cold temperatures as you might have in space. So it mimics the conditions in space.
To recreate the conditions of an asteroid surface for asteroid mining tests with greater accuracy, scientists use simulants, composed mainly of silicates such as feldspar and quartz. Most of the simulants are similar to materials we would find in carbonaceous chondrite asteroids, which are the most abundant and most closely studied. Their composition is based on a variety of data sets, including laboratory analysis of meteorites, observation of bolides, remote sensing of asteroids, data from asteroid missions, and scientific modeling. Thanks to all of this data, scientists have been able to produce the simulants with great accuracy in mineral content and particle size.
What we have here are Asteroid simulants. We're making simulants of asteroids. We get the raw material for these simulants from our collaborators at the University of Central Florida, who are experts in the mineralogy of asteroids. And then we're making asteroid surfaces. We're creating a simulant of the asteroid surface. This is one example that kind of mimics a large boulder on an asteroid. These here are smaller boulders or cobbles. Friable because asteroid surfaces have rubble strewn across them, of varying sizes from boulder size to hand size to little pellets.
When it comes to developing mining techniques for asteroids, drilling and anchoring are two processes that have to be closely studied due to the peculiar properties of these small celestial bodies. In the case of drilling, the microgravity plays an important role, as the almost total lack of gravity creates different conditions for mining on Earth.
One thing to understand about asteroids is that the gravity on asteroids is very low. In a lot of processes we use for mining on Earth, we use the weight of a vehicle to hold it down so you can dig. But you can't do that on an asteroid.
The data gathered in the microgravity research in core drilling will provide conclusions on the efficiency of drilling to collect asteroid material, as well as the dangers presented by having loose debris so close to the drill operator. After collecting data on the exit patterns of the debris in a microgravity environment, an appropriate capturing device can be designed to ensure maximum collection. Developing a device that collects excess debris will also decrease the potential for damage to the drilling device.
What you can do is build systems that grip the asteroid or harpoon it and create an anchoring point onto the asteroid. That then gives you a way to hold onto the asteroid while you use some other device to scoop up the parts of the asteroid and move it into some processing system, like cut up a metallic asteroid so that you can take in metals and refine it within some microgravity refining system. We can study the methods you might use to anchor to asteroids. Might look a little bit like a drill or a harpoon, or even just kind of gripping devices that hold onto the surface of an asteroid. And we want to study them or want to determine ways to design the anchoring equipment so that it provides enough grip so that you can then scoop and scrape and cut the surface of an asteroid.
Considering that the surfaces of many asteroids are made of boulders, pebbles, and little grains, anchoring processes could eventually be really difficult. That's why it's useful to do testing to study the best way to penetrate and anchor to that surface.
What we're basically doing is penetration testing. So what we're doing is we're taking this probe and we're pressing it down into the regolith, into this simulated regolith, because it's made from stuff here on Earth to simulate what we would find on the asteroid. And when we press it down in, we measure the forces that occur both in the upward in all different directions, as well as the torques. The reason for doing that is to kind of understand if we were to land on an asteroid and we wanted to press into the soil, say we want to anchor, or we want to extract water, or we want to build a habitat, or we even just want to understand how the surface of the asteroid is going to move or react when a meteor hits it. We use liquid nitrogen to freeze them because the surface of an asteroid could get as cold typically as 35 Kelvin. We've sealed the liquid nitrogen inside this. What it is basically, it's a probe that can move around in 6 different directions. So it has, can move in X, it can move in Y, and it can move up and down in the Z direction. An auger, so it has flutes that run around it. Those flutes allow material to travel up, so it's sort of like your typical drill bit that you would, or like a screw that would go into a piece of wood or anything like that.
This test analyzes the forces involved when drilling or anchoring on a rocky surface which would be useful for the future asteroid mining techniques. One of these techniques is surface mining. On some types of asteroids, material may be scraped off the surface using a scoop or auger, or for larger pieces, an active grab. There is strong evidence that many asteroids consist of rubble piles, making this approach possible. Another technique is shaft mining. A mine can be dug into the asteroid and the material extracted through the shaft. This requires precise knowledge to engineer accuracy of astrolocation under the surface regolith and a transportation system to carry the desired ore to the processing facility. The magnetic rake is one intended for metal asteroids. Asteroids with a high metal content may be covered in loose grains that can be gathered by means of a magnet. The question now is whether asteroid mining nowadays is really a feasible industry if we think of it as a mining industry that provides resources for the Earth.
The cost of sending a spacecraft to the asteroid belt used to be about the same as if the spacecraft were made of pure platinum. So it didn't seem to make sense to go out and get diluted platinum from something that cost you so much to send out there.
Nowadays, the most viable option is to mine and process the resources in situ. As with our present technology, the cost of sending a spacecraft and returning it fully loaded back to Earth would be extremely high.
What is more attractive is to use the resources from that asteroid to use it in space. That makes it more economically feasible because bringing it from Earth is extremely expensive. Bringing water from Earth, bringing the iron and the nickel from Earth is very expensive. So then it becomes economically feasible to extract the resources from the asteroid.
Maybe in the future, if we are able to radically reduce the cost of space missions, it could become feasible.
In the asteroid belt, there are orders of magnitude more materials out there than we've ever imagined. So what you have is companies that can get very excited about claiming these future sources of mineral wealth that will eventually become starships and space colonies.
That dream of space colonies on asteroids might not be so far in the future. We now know that there are asteroids made almost entirely of metal that could potentially become an almost endless resource for industries on Earth in the future.
The existence of platinum group metals was probably the very first resource that attracted interest from companies to go and extract those metals from asteroids. Because of their high value on Earth, there's plenty of platinum on those asteroids. In fact, it has been said that an asteroid a couple of kilometers in diameter or in size has more platinum than has ever been mined and probably will be mined in the next 50 years on Earth. The problem again is it economically feasible to go after that platinum? Is extracting the platinum from Earth more expensive than on asteroids? Not at this moment. The amount of money that you need to launch a rocket to get there to extract the platinum at this point is not competitive. But again, at some point, it may become so hard to obtain the platinum from Earth that it will make sense to actually go to an asteroid to do that. The other thing to consider is the moment you start bringing those large amounts of platinum to Earth, the price of the platinum will just collapse immediately. All of a sudden you will have all this metal available that it changes completely the price that we put on this. Obviously, if there's more demand for it, if now that we have more and we can use it in many more applications, then it will make it much more attractive to go after them.
This emerging industry is about to kick off. Undoubtedly, the key game changers are asteroid mining companies that are investing mainly in the development of technologies to make this industry economically feasible. Among the asteroid mining companies, there were two that led the race until recently: Deep Space Industries and Planetary Resources. However, due to the low feasibility of the mineral extraction, they are now in a redefining process. In addition to those, there are other asteroid mining companies, each focusing on specific aspects of this industry, such as the production of propellant from water located in the asteroids, the development of robotics, or the search for the right targets. One of them is TransAstra.
TransAstra has a business plan that's focused on extracting rocket propellant from asteroids. You could call that asteroid mining if you want. And then using that rocket propellant to fill refueling stations in space, to refuel NASA spacecraft and private sector spacecraft. For NASA, it would be refueling spacecraft that are taking astronauts on a mission of exploration. For private sector, we can refuel space tugs that deliver satellites to their destination orbits.
TransAstra is a new kind of aerospace company intended to contribute to the development of the concept of the transcontinental railroad of space. Their vision is for humanity to become a spacefaring species homesteading the solar system.
We can build the transportation network. It's kind of like the transcontinental railroad of space that will make it possible for industries to go in space for a profit.
Their ultimate goal is to turn thousands of asteroids into refueling stations for NASA and commercial spacecraft, opening the frontier for NASA human exploration and commercial industries beyond imaging satellites and telecommunications. They aim to lead the work in supplying services for 21st century industries of asteroid mining, space solar power, space tourism, and manufacturing in space.
That is going to create the greatest industrial revolution in the history of mankind. And we're standing right here at the moment in history when it's about to happen.
The company has a clever mining technique called optical mining that benefits from the solar power to mine the water on asteroids, water to be used as propellant.
One of the best energy sources we have in space is the sun, and that's one way we can use that is by building reflectors that concentrate sunlight to extract and process materials in space. An example of this is a technique called optical mining that is invented by TransAstra and Joel Sercel. We are collaborating with TransAstra to help understand the basic process of concentrated solar interaction with minerals of C-type asteroids.
TransAstra has invented a process that we call optical mining. Optical mining is an approach whereby highly concentrated sunlight is focused onto the surface of an asteroid or other volatile containing body. The highly concentrated sunlight heats and thermally fractures, means it breaks up the surface. So you have the surface of the asteroid or other water-containing extraterrestrial body. The highly concentrated light hits the surface, and as it heats the surface, it fractures it due to the heat. What's really exciting is that the little particles of the broken surface then individually heat up very fast, and all you have to do to get the water and other valuable compounds out of the asteroid is heat it up. The water comes out as vapor. That vapor actually cleans the surface and exposes the next layer of surface and for the sunlight beam to fracture, and it's a continuous process.
The optical mining technique has been tested in vacuum chambers at the Center for Space Resources of the Colorado School of Mines. They use hydrated mineral-type simulant, similar to the material found on the surface of an asteroid.
I have the chamber itself, and that makes it a vacuum and allows me to put in samples and make them hot or cold, depending on the kind of test that we're doing. Then I have a lamp on top of it, and that allows me to have sunlight focused down, or simulated sunlight focused down onto my sample. And then inside the chamber, I have samples of many different kinds. We will get the light out using just sunlight. So we'll concentrate it down to a spot, and a column of water vapor will rise from the surface. So this will probably be the first technique that people use when they're gathering space resources. So after the ice on top of the regolith turns into steam and is sublimated, and it's going to form a little cloud, we're going to take a tent and put it on top of this cloud. The tent is going to be colder than the ground underneath, and in this situation, whenever something is the coldest, that's where the ice will stick.
TransAstra is developing an innovative mission concept called APIS, an acronym for Asteroid Provided In Situ Supplies, that includes an autonomous spaceship that will be launched on spacecrafts to reach asteroids.
So what we're going to do is we're going to build a spacecraft that's about the size of a pickup truck and launch it out to an asteroid that's about the size of a house. And then this spacecraft that's about the size of a pickup truck will have inflatable structures, and it'll have a bag that it uses to inflate and then enclose the asteroid. And then the solar concentrators will pump sunlight in, and then through the optical mining process, we'll excavate the asteroid, extract the water, and freeze the water in ice bags. So this honeybee mission, as we call it, will take about 6 months to get to the asteroid. It'll do mining for about 3 months, and then it'll take 6 months to get home, and it will bring back 100 tons of ice. And that's the first small industrial scale mission to bring back an economically important quantity of rocket propellant that can change the economics of space. And we think that that will launch a gold rush in space to harvest asteroid material and also material from the lunar poles. And that will make it so inexpensive to operate in space that it will become practical to do things like build solar power stations in space where the sunlight is much more accessible, much more consistent, much more cost effective if you can launch into space inexpensively enough.
When it comes to benefiting from asteroid resources, one of the greatest challenges is knowing which are the best targets among the thousands of asteroids floating in space. Optical Engineering is a company focused on that field. Their goals are to develop technical solutions for the detection, discovery, follow-up, and characterization of near-Earth asteroids.
We're still working to find some of these bodies with our telescopic surveys, and it may actually take a next generation of telescopic surveys, or possibly a space-based telescope specifically designed to find these kinds of objects.
Up to date, more than 10,000 near-Earth asteroids have been discovered. It's not an easy task to find and to follow them up. But thanks to the Minor Planet Center data and tools, Optical Engineering has been able to study and track those objects. The biggest challenge is to characterize them in terms of size, rotation periods, and spectral composition. Until now, less than 10% have been well characterized. It's estimated that with present technology, it will take about a century to study the entire known population.
We use telescopes to look at the spectra of asteroids, and in the spectral signature you can see different things that tell you what it might be. So you can determine if it's a metallic asteroid, or a stony asteroid, or a carbonaceous.
They are now focused on developing accessible technology for characterization to keep pace with discovery. They are working on quick visible spectroscopy and fast cadence light curves that could be obtained with a telescope in just a few days. as well as in long arc astrometry to be used for phase curves that should take months. All of these would undoubtedly accelerate the rate of characterization of near-Earth asteroids, which would help to analyze their potential as resources for mining purposes.
I'm really excited about asteroids, the near-Earth asteroids in particular, as targets for future human and robotic exploration.
Other companies like Off-World are focused not on the study of the asteroid's properties, but on the development of robotic devices to mine autonomously. Their ultimate goal is to create a squad of autonomous robots working under human supervision on other planets and asteroids, which will allow human beings to spread beyond Earth.
While these little asteroids offer us a lot of benefits to go to as targets, there are still a lot of challenges involved with going to a little asteroid like that.
The environment out there is extremely harsh. Human settlers will have to cope with long, deep space journeys, lethal cosmic radiation, zero or lower gravity, or artificial atmosphere. Off-World thinks the best way to minimize the risks of establishing a permanent and sustainable settlement on other planets would be to have a local robotic army that would be in charge of the hard work. Building landing pads, excavating underground habitats, extracting water ice and materials, making drinkable water, breathable air and rocket propellant, manufacturing basic structures and solar cells, producing electricity, eventually replicating themselves. As the asteroid mining industry grows, thousands of mining robots would be needed everywhere. These robots should be small and robust enough to survive launches on rockets, solar electric powered. Extremely adaptable to work in a wide range of environments on asteroids, the Moon, or Mars without a major redesign. Autonomous and fast learning to survive without on-site human supervision, and modular and reconfigurable to maximize the reuse of launched hardware. The robots should also have self-replication capability using local resources and should be able to manufacture the first off-world computer chips, closing then the robotic self-replication loop. All these asteroid mining companies are now leading a race that could push human beings beyond their natural frontiers to colonize these small, mysterious, rocky worlds in the near future. The potential colonization of asteroids is not an easy task at all, as they are very harsh environments for us, without any shielding from cosmic radiation, as they have no atmospheres or magnetospheres, with extremely low gravity and with a very high chance of collision with other celestial objects. The two main reasons that justify moving off Earth to asteroids would be to benefit from their almost unlimited resources, as well as their colonization as a risk mitigation strategy to ensure the long-term survival of our civilization in case of a planetary catastrophe.
We really want to get the asteroids that are closest to Earth's orbit. There's enough material in those near-Earth asteroids to support maybe 100 billion people living in Earth orbit. There's 1 million times more material in the main asteroid belt. So after we've got people to orbit, we're using this material to live and work and build cities, we can expand to a huge civilization circling the sun. That's pretty exciting.
You're looking for stuff that you want, and specifically, if you're going to turn an asteroid into a place for people to live, you want the kinds of things that would support life. Like especially you would want a certain amount of water. You would want components that you could turn into soil for a greenhouse so that you could, grow your own food. You would want sufficient, metal concentrations that you could make your own building materials from the base metals. You would want enough precious metals that you could export precious metals to sort of feed yourself and have things to trade with other, asteroid colonists or with the moon people or the Earth people or whatever.
Throughout our history, opening new frontiers has thrilled generations of explorers and pioneers. Asteroids could be considered the next frontier. The fact that asteroids are small rocks floating in space offers several advantages, but also some disadvantages. Their extremely low gravity, because of their small size, is one of the greatest advantages. This low gravity would make construction of huge structures much easier and would reduce the costs of landing and launching rockets in comparison to the Moon's or Mars's higher gravity wells.
The gravity is so low on these little objects that it's more akin to going and docking with the International Space Station or rendezvousing with something like the Hubble Space Telescope. So you're not going to be walking on these objects, you're going to be floating near them. And it makes, in some aspects, it makes that portion of doing a mission to one of these objects a lot easier.
Another pro would be the large number of possible sites because of their numbers, with over 300,000 asteroids identified to date, as well as their variety in chemical composition, with carbon-rich, metallic, and stony asteroids.
There are metallic elements and water in the surfaces of those little asteroids that are great resources for us out there in space once we have a thriving working economy out there. If you want to make rocket fuel to power your spacecraft that are moving around the inner solar system, it's a lot easier to make that fuel from the material on a little object with very little gravity than to have to haul it off the Earth all the time and lift it out of this deep gravity well. So the asteroids have great benefits for us, exploration and science and resources. I think they're wonderful destinations.
However, to make this future mining industry a reality, we need to solve several challenges such as asteroids' low gravity and zero atmosphere, which make them vulnerable to cosmic radiation and to the impact of small objects.
We've never actually had any experience in human spaceflight of working in a very low gravity environment that's very geologically dirty. Unlike on the Moon, where if you stir up dirt, it very rapidly settles again, on a little asteroid, if you stir up the dirt in that environment, it's going to stay around you in orbit around that asteroid for the entire rest of the duration of your mission. It's going to contaminate your spacecraft, it's going to contaminate your suit, it's going to make the visibility environment difficult. So there are challenges like that. Combining the challenges of a zero gravity EVA, a spacewalk, with the dirty environment of something like the Moon is something we have no experience with. And that's going to be, I think, one of the biggest challenges in human crews working around these little objects.
In a not-so-distant future, asteroids may become our new industrial target, a place to mine to benefit from their resources, used not just on Earth, but especially in space.
We can build the infrastructure that moves industry in space, not in 20 or 50 or 100 years, but starting in 3 or 4 or 5 years. And we can be harvesting rocket propellant in less than 10 years and building the transcontinental railroad to the solar system.
They might also become pit stops on the long journeys to Mars, and who knows, to our new home as well.
That is where the value of asteroids really lie, as they become gas stations or pit stops or stepping stones in our process to explore further and further into the solar system.
We are about to go one step further in the conquest of space, as the asteroids could soon become our next frontier.